Welcome to Algebra 2. Make sure you have your books open to this lesson right here. Lesson 63, we're learning about unit circles. Make sure you have this in front of you. This is your unit circle. This will be your best friend for trig. This helps you a lot with dealing with these problems. Again, if you don't have this, if you lost it somehow within the week that you were at home, make sure to email me. I can send you through PDF. You don't even have to print it out. You can just look at it on the computer. But you make sure you have this in front of you, especially when you're taking your quizzes. This will be very important. Keep in mind quizzes. It's a corona talking. Make sure your quizzes, they're daily. Make sure you look on it every day. There's a quiz every day. And this Friday, there will be kind of like a test. There'll be about 15 or 20 questions, so you can have a review on what you've learned. So again, this is not just you watch, you click random answers, you watch, you click random answers. This is for your educations. Those of you who want to study and pursue engineering, nursing, different things like that, this is very viable. So again, for master's programs and all that, you have to take calculus, take things that are higher. So now, looking at this lesson here, a couple things about the unit circle. A unit circle, it equals 360 degrees or 2 radians. So a whole circle is 2 radians. So 0, you start this way all the way around counterclockwise, you get 2 radians. Here, halfway is 1 radian, but altogether it's 2 radians there. Make sure your calculator is in radians form. So if you put in radians form, it's this button right here. This is for the TI. Make sure it's in the correct one. Degree, radians, GRD, radians, equal sign. And then your pi now turns into radian form and it doesn't turn into pi. Now keep on going to what we're learning. Here we have different things that we need to focus on. Degree to radians. So let's say we have 35 degrees. We have to turn it into radian form. That means we have to put the pi over. If you look here, all of it's already in radian form for you, but the higher the number gets, this is only until 360. So if you deal with numbers like 540 and etc., you know, things that are bigger than 360, you have to convert some of them into radian form. And that's where we have, that's where we have the equation here. You multiply your degrees by your radians divided by 180. Next one, from radians to degrees. So it's the other way. It's your radians, so it's going to be a fraction. You're going to multiply that by 180. And then you're going to get it in radian form. So radian form, it has a symbol, that symbol there, and you include the word radians to it. Looking at this first one, looking at this first one here, you have negative 30 degrees. They're saying to convert it to radian form. Your circle does not have negative 30 degrees, so guess what? You use this here. According to degree, we're trying to put it into radians form. We have to multiply negative 30 times pi radians over 180. So when you're multiplying this across, you end up with negative 30 radians over 180. Put the word rad. So now here you have negative 30 radians over 180. So now you have to simplify it more. So I would recommend you writing the words. For the sake of space here, I'm not going to write the word, but this is putting it in radian form. Again, it's not pi. So now you have negative 30 radians over 180. You simplify the fractions, so negative 30 over 180. So you're not putting decimals. We never want decimals. If you use your calculator and you hit the word simplify, so put it in fraction mode and simplify it, it can do that for you. Or you can find the common number in each of these, which would be 30. So simplify it even more. You'll end up with negative radians over 6. And this is negative 30 degrees in radian form. Next one, B. We're going to convert it to radian form, but we're going to put it in degree. So we have 3 radians over 4. According to this, all you do is multiply it by 180. So when you multiply it by 180, all out, so 3 times 180 divided by 4 radians, you actually end up with 135. So how I show it is they have radians here is 180 divided by radians. Right here, they said likely the radians, they cancel out here. So if we were to multiply 3 radians by 8 divided by radians, these radians would cancel out. So I've noticed when you're putting in degree form, you don't have your degree there, just always multiply by 180, you'll end up with a number. So just the fraction, you're gonna multiply it by 180 and you're gonna put it in degree form. So 3 radians over 4 is equal to 135 degrees. Hi. Sorry, someone had a question and interrupted the video. Anyways, here Again, for degrees to radians, you're multiplying by radians over 160. So you're gonna have a fraction, simplify the fraction. For radians to degrees, don't worry about the radian sign. Just multiply the fraction 3/4, multiply by 180, you'll end up with your degrees there. Now for the next part, my camera's all messed up now. For the next part, we have the cosine and sine. I don't know if I put it in your worksheets. I don't remember if I did or not. But sine and cosine each mean something. So here, for coordinates, it's usually x and y. But in this case, now that we're dealing with unit circles and we're dealing with trig, it's cosine, comma, sine. So sine isn't first. Usually we see sine, cosine, and tangent. But in this case, it's kind of backwards. It's cosine as in reference to x, sine as in reference to y. So if you see there, p of x comma y is equal to cosine comma sine. Keep in mind, cosine is x, sine is y. And to find tangent, it's sine divided by the cosine theta. So these are all thetas, just the degrees or the radians, what you have. So basically it's y divided by your x coordinate. So we're always looking at these. In calculus, you're gonna learn them as terminal points, but for you, they're just coordinates. But remember, it's cosine, comma, sine. Cosine, comma, sine, and each of these are in reference to every angle here. Now let's go ahead and look at example 2. Example 2 tells us to find the sine of 120. These are actually very simple. All you have to do, simply look at your unit circle here. I try to make it easy as possible. This is just the best reference so you understand it better instead of doing the whole process. To find each of these, they deal with the 45-45-90 triangle and a 30-60-90 triangle. And that's what all of these measurements, that's how they get all these numbers here. So now, if you go to 120 degrees, so that should be right here, you have -1/2 comma radical 3 over 2. So here you have, I'm gonna write it down here, -1/2 radical 3 over 2. So now you have to figure out, sine is only one measurement. It's not the whole coordinate itself. If we go back here, sine is considered the y coordinate. So that means the sine of 120 is radical 3 over 2. It's not the whole coordinate. I just write it down so you can see it. But remember, sine is the y coordinate between those two terminal points. B is where it gets a little trickier because sine and cosine is just from looking at it. Tangent. So tangent of 11 radians over 6 or a tangent of 330. What I do to simplify in degrees, simplify a 2-degree form for these for the radians, I do 11 times 180 divided by 6. So here, if you did 3 times 180 divided by 4, you end up with 135. If you do 11 times 180 divided by 6, you end up with 330. So then we have the tangent of 330 is x divided by y. So tangent is sine divided by cosine. So if I go to 330 in my circle, it's right here. I have these set of coordinates. So I'm gonna go ahead and write these down just to show you. So 330 is radical 3 over 2 and -1/2. This is x, this is y. According to tangent, we have to do sine divided by the cosine. So it's the sine of 330 divided by the cosine of 330, or y divided by x. So here the sine will be considered -1/2. The cosine will be considered radical 3 over 2. You're gonna have a complex fractions. All tangents will require complex fractions. So it's your sine of 330 and your cosine of 330. So -1/2 divided by radical 3 over 2. Again, cosine of theta, comma sine of theta. Now, to get rid of this, we have to try to simplify. This is not simplified. We go ahead and multiply it by the reciprocal. The reciprocal of the denominator is 2 over radical 3. So now you have this here. So this whole thing cancels out. Now you have -1/2 times 2 over radical 3. These cancel out. So you're left with -1 over radical 3. Another rule for simplifying these, especially these type of problems, is you cannot have a radical in the denominator. Now we apply another rule. To get rid of a radical in the denominator, you multiply the top and the bottom by the radicals. So then you get negative radical 3 over whole number 3. and that will be your answer for that one. So just make sure you're going step by step. There's a complex fraction. If there is a radical in denominator, if it's a numerator, we don't care. Denominator, just the bottom, we make sure it's all simplified for you. Now the next part is dealing with the reference angles. We won't be dealing with that much today, or actually for this year, because we have everything here. Typically for reference angles, you deal with just the 30, 60, 90 right here, this first portion. And to find the reference angle, you use whatever is on the other side. For example, 135 is right here. The reference angle will be this other part here between the x-axis. So it's whatever angle you have, and it's the other side of the angle by the x-axis. So in this case over here, if I were to find this measurement here, it's 180 minus 135. My reference angle will be 45 degrees. And they're saying you can use that to figure out and solve for the different problems here. You don't have to do that. Why? Because you have everything up here. So here it says, find the sine of 135. We have the complete chart. We have this in front of you. So 135 is this measurement right here. So sine is considered the y coordinate. So if we have sine of 135, we have this coordinate here. We look at the y coordinate. That would be radical 2 over 2. And that's your sine. Cosine. Cosine, again, for 135 is considered that terminal point here, that coordinate. And that is negative radical 2 over 2. Tangent. Again, that means complex fractions. You're dividing the y coordinate. I labeled sine for y. I labeled cosine for x, so I don't get confused. So it's y divided by x. Y is considered radical 2 over 2. Cosine is negative radical 2 over 2. You have a complex fraction, get rid of the denominator. To get rid of it, multiply it by the reciprocal. Reciprocal will be negative 2 over radical 2. So this whole thing cancels out. And if you see here, the 2's cancel out and the radical cancels out. But you're left with a negative, and it's always a negative 1. It doesn't turn into 0, it just turns into a negative 1. So your tangent of 135 is negative 1. Now the last part is arc length. Arc length formula is the measurement of this side right here. Arc length is this outer portion here, if you remember from geometry last year. So it's the outer portion, we're trying to find the measurement for that. To find it, it's your radius times your radians. So radius times your radians. This has to be in radian form. So if you have degree, you have to convert it to radian form. So example 4, if I were to erase this here, we have to find the measurement of this outside part here. So here, we don't have a measurement for the outside part here. There you go. We don't have the measurement for the outside part here. So then we go ahead and we find that measurement. This, we don't have anything, so it's gonna be S. Your radius. You have a radius here, it's the same problem on your book, example 4, and that's a number 5, times your radian, so the degree of the angle. The angle is 2 radians over 5. And then you solve for it. Again, this has to be in radian form. So this is in radian form, you're good. So then, to simplify, remember when you're multiplying whole numbers and fractions, you always multiply the top two. So this will be simplified to 10 radians over 5. And to simplify this, do 10 radians, the pi symbol. Make sure you have it in radian form or else you'll get a completely different answer. So if you have a completely different answer, change it. If not, you could just leave it as, 2 radians. But here, we're trying to simplify this as much as we can. Sorry, this is 3. 2 radians over 3. So then 10 radians over 3, to simplify, that's 2 radians over 3 over here. You get about 10.5 centimeters. So you have to solve it out, but again, your calculator has to be in radians form for the calculator to understand this is radians, not pi. B, so this last one, this outer circle is 225, and this measurement, this radius is 2.5. So we have S equals R theta. Before we go ahead and solve for this, we don't have the measurement here, but we have to find the radius, which we have here, which is 2.5. This is what we're gonna have to try to solve for. Here we have 225 degrees. Let me move the camera. We have 225 degrees. We can't use degree form. If you try to do 225 times 2.5, you won't get the same answer because it has to be in radians form. So now, 225 degrees, you have to convert to radians. So that goes back to what you learned on your board, your previous board. Yep, it's right here. So degrees to radians, it's your degree times radians over 180. So now you have degrees times radians over 180. You multiply that out and you get 5 radians over 4. So it'll be 225 radians over 180, 225, 180. And then you simplify the fraction. The easiest way is just to put it in simplified form when you calculator. Now, you go on to solve for it. So 2.5 times 5 radians over 4. And then you'll end up with 12.5 radians over 4. And then you'll get an estimation of about 9.8 feet. Again, look at the book for the proper way. It has to be in radians form. That's the most important part. If you have it in degree form, it's not going to give you the right answer. So here, I did 2.5 times 5 radians divided by 4, and the calculator was saying that there was some sort of error. It's because you have to make sure you're dividing. You're now putting it as a fraction. So 2.5 times 5 radians, comma 4, whatever your calculator does, it won't give you the same answer. Again, if you have any questions, make sure to email me down here. You're going to have a quiz on Friday for all that you learned the past week. I want to make sure that you're learning, you're continuing in this. This is trigonometry, so it's practice, practice, practice. Miss you guys.